طب دكتور ينفع لو أصور الوايت بورد بتاع the problem that we solved right now?
What?
Can I just take a picture of the problem you just solved?
I have okay. Effectively,
Because I don't
once
think it was being recorded.
once I have I'm going to do it once again.
Oh, it's gone?
B1 is mu naught I multiplied by 3y over 2 4 y of B2 is mu naught I multiplied by 2 y of B is B1 minus 2 y y 3y 1 over R minus 1 over R. So I 3 over 8 multiplied by 1 over R. So I over 60. Okay?
Yes. Thank you, doctor. Sorry,
Yeah.
you have to solve it again. And by the way, doctor, would this question also be cancelled? Like omitted?
The figure shows cross-section of three parallel wires, each carrying current 15 ampere. The current in wire A and C are out of the paper, while in wire B is into the paper. If the distance R is 5 millimeter, what is the magnitude of the force on a 4-meter length of wire C? So from here, I'm going to calculate the magnetic field from A to C and the magnetic field from B to C. And we are going to say that the magnetic force will be I L cross the magnetic field. So the magnetic field from the wire A is mu naught I over 2 pi multiplied by 2R.
This is from A to C?
ثانية واحدة بس.
Okay.
I wish to be able to write on your screen.
I think you can.
That's what I'm looking for.
There's an option called annotate. I think that this option lets you.
Where can I get it? I have here share screen. I have one participant, multiple participant, advanced option, and advanced option. I don't know.
Uh, Try pressing on more. Or or is there like an option, like an options button or something like that?
Okay, red. You can see this red bar.
No, I can't.
You
Yes, now I can see it, yes.
okay? This
But
again.
it's fading when you're writing on it.
The figure show cross. So I have B of A or A. B of A equals U naught I over 2 pi multiplied by 2R. Right?
Yes.
And its direction. This is BA. And BB is mu naught I over 2 pi multiplied by R. And its direction downward. So the total magnetic field B is BB is greater, so BB minus BA would be mu naught I over 2 pi multiplied by 1 over R minus 1 over 2 pi. So from here is mu naught I over 2 pi, and its direction could be downward. This is- And I have the current in the wire C. So F is I L cross B. So the current is perpendicular to the magnetic field. The current is going outside, and the magnetic field is downward. This means that the force will be in this direction. Its magnitude is the current I multiplied by 4 meter multiplied by the magnetic field, which is mu naught I over 2 pi multiplied by 2 pi. Now, let us calculate this. The value of I is 15, so 15 multiplied by 15, 15 squared, multiplied by 4, multiplied by 4 pi, 10 to the power minus 7 over 2 pi multiplied by 2. What is the value of R? 5 millimeter, 0.205. This is 4 pi. This is 4 pi. 15 squared multiplied by 4. So 15 squared multiplied by 4 multiplied by 10 to the power minus 7 over 0.005. Calculate this question.
Okay.
One second, I will take.
All right.
Have you calculated?
Yes.
Which one?
I got 18 millinewtons.
18? 18
Yes.
nanometer. So the answer is D.
Yes. Doctor, would there be questions like this on the exam or they would be simpler?
The question what?
Would there be questions like this on the exam or would it be simpler than this?
Maybe, but يعني, I'm not sure.
Oh, okay. I hope يعني it will be easier than this.
يعني we will see tomorrow.
إن شاء الله.
إن شاء الله.
أنا المشكلة I had a midterm yesterday فأم like يعني technically studying today. So I'm kind of worried بس I don't know. I hope it turns
بص
out.
يعني my advice for you, just be relaxed.
Be relaxed. I will try my
Just be
best.
relaxed. Be relaxed.
Yeah, I will try my best. Usually I have an issue with that. Um, I'll find another question. I had this question. It's
Wire carrying current is bent into the shape shown one straight line segment and semicircle arc and lies in the XY plane. What is the magnitude of the total magnetic force on the wire? If it is placed in a uniform magnetic field that is directed in Y direction. Y direction. Okay. So effectively here for this part, I have two components. Component in Y and component in X. The component in Y in the same direction of the magnetic field. So the component in Y will not be affected by the magnetic field, but the component in X will be affected. So actually, in this case, this is equivalent to a wire extend from 2R to minus R, or in other words, the total length is 3R in X direction and carrying current in X. So the force F will be I multiplied by 3R in negative I direction cross the magnetic field B in positive G direction. I cos J is minus K, so this would be I cos J. So this is minus 3R I B. So the answer is the answer.
okay. So we ignore the y-axis, right?
Not
And
ignore, not ignore. Any current here like this can be analyzed in two components. One component in y direction, which will not be affected, and x component. So I'm going to analyze it. So by analyzing each component here, I'm going to take the x component and find that it will be extended from minus R, from R to minus R.
okay, all right.
Okay?
Yes. And the y-axis is not affected because it's parallel to the magnetic field, so technically the angle is 0.
Yes.
Okay, all right. Um, there's also this question here. It's like it also talks about the direction.
Rectangular, this is moving.
Oh no, it's not included?
Yes.
Okay. What about this question here?
Hmm. Two very long straight wires carrying current perpendicular to XY plane and along the Z axis, one carries ampere and passing through X equal to, and the other is passing on the what is the magnitude on the resulting magnetic field at the origin. Yes, the good point. One carried 50 ampere and passing through X equal 5. Both of them in Z direction, and Z direction is outside. Correct. So here, this is one. I have magnetic field from one holding to the right hand rule. This is B1. And B1, B, mu naught, the value of R is 50 over 2 by the value of R is 0.25. And 0.25. And this would be downward. The magnetic field due to the second would be this B2, and B2 would be mu naught multiplied by 80 over 2 by times 0.04. He wants the total magnetic field. So B total would be the square root of B1 square plus B2. This is the total magnetic field. So we are going to calculate B1 and B2. So from here, mu naught over 2 pi is a constant. So we can say that mu naught over 2 pi square root 50 over 0.45 all of them square plus 80 over 0.44 square. So from here, 50 over 0.05 equals 1000 square plus 8 over 0.04. لازم نعملها لوحدها مش تاني. I'm going to open bracket 50 over 0.05 close the bracket square plus open another bracket 8 over 0.04 close the bracket square. So from here, this is 5 millions square root this 1 million would be 2236 multiplied by mu naught is 4 pi 10 to the power minus 7 over 2 pi. So it would be multiplied by 2 expansion 7 negative. So it would be 4 multiplied by 1 expansion 6 would be what I have is 447 micro Tesla. So the closed answer is C.
Oh, okay. Doctor, I have a question. Well, here, how did you get the directions of B1 and B2?
Actually, I have obtained from the right hand rule. I put my thumb in the direction of the current. I rotate my 4 fingers at the observation point, so it will be downward.
Oh, okay. Oh, so here, like, we're using the right-hand rule for, like, long
This
wires,
is the
right?
current. This is the magnetic. This is the current. The current is outside the magnetic field. ماشي؟
ماشي. Here we use the right-hand rule for, like, wires, صح? Not the other one.
Exactly.
Okay. And doctor, what about this question here? Question 28.
For the circuit shown, what is the rate of change of the current in the inductor when the current in the battery is 0.5 ampere? Good question. So the current here is 0.5 ampere. So the potential here the current is 0.5. Yes. So the potential here is 10. So the potential here is 2. If the potential here is 2, so L dI by dt is 2 volts, and the value of L is 10 millihenry. So dI by dt is 2 over 10, 10 to the power minus 3. So from here, this is 1000, 1000 over 2, this would be 200 hertz. So the answer is
Doctor, معلش, I didn't really cover this concept yet. Could you please explain like what you did?
once again. What I have done here, he said that the current in the battery is 0.5 ampere.
Okay.
So this enter 0.5 and so forth. Okay. If the
Yes.
current passing through this resistor is 0.5 ampere, which means that the potential difference between this point and this point is 0.5 multiplied by R. So I have potential difference here is 10 volts. ماشي?
Oh.
So according to Kirchhoff voltage law, if I'm starting from here, this is 0, this is 12, and I have some potential here, and I have negative 10 here. So what is the potential here? It's 12 minus 10. So the potential here is 2 volts. The potential here is the potential on this resistor and in this inductor.
Oh, okay.
So the potential of the inductor VL is 2 volts, and VL is L dI by dt. And already I have the value of L. So dI by dt is this 2 volts over the value of L, 10 to the power 10 minus 6. ماشي؟
Oh, gosh. One second, I will open the other exam.
مش عايز نصعب.
Sorry?
ماشي. Okay. Do you have other questions?
Yes, just one second.
This question? Okay. Can you start it? Yani, you are
Uh,
picking up.
yes,
Go
sorry.
down, slightly down, because I don't read it.
Oh, okay. Okay. Oh no, this is not the question. Sorry, I'm sharing the wrong screen. One
This is
second.
not the question. Okay, give me
No,
the
no,
question.
no. Okay, one second. Oh, just 1 second. Can you see my screen now? This is the
Yes.
question. Okay.
All right. Let's take it. I know this problem, but I don't remember that is included with us because this will include finite section of straight lines. We don't have finite sections of straight lines.
Uh,
We have infinite sections. Okay, okay, let us let us try.
okay. Okay, for questions like this, usually we look at the infinite ones.
Here I have semi-infinite line. And here I have two sections. I have semi-infinite line for me. So this one will include mu naught I over 4 by L because this distance is L. And this part will include zero magnitude.
Yes.
The remaining is this one. So this one is finite section. No, we don't have the finite section in this course now. The
Oh,
finite section is not included.
so why is it finite? We're not given
But
values.
at least from the point of view, it is outside or inside, it is inside the screen. The magnetic field is inside into the page. So the answer should be one of these three ones. And it should be greater than the value. So here mu naught I over 4 by L. Mu naught y over 4 by L is from this semi-infinite. Okay? So mu naught y over 4 by L, 1 over square root 2, no? So the answer is between B and E.
Oh,
Mu
okay.
naught over, effectively, I don't know how to calculate it from the rules which we have these square parts. So I don't have a square here. So the answer is between B and E into the base. Which
Okay.
one? I'm not sure.
And so, doctor, these type of questions are not included because, why? Just so I can avoid these type of questions.
Hmm?
Like, why are these not included? Just so I can avoid similar ones, like when I'm solving the other questions. Like, why are they not included?
It is not included. It is not included.
Okay, all right. Um, Now, what about this question here?
Here it is similar to a previous question which we have discussed. I have different arcs. So I have arc 1, arc 2, and arc 3. And the straight line sections are 0.
Yes.
So for arc 1, here the current is 2 ohm, 3 and 2 ampere, half circle of radius 4 meter, and this 2 meter. So these two and the current here, I'm going to assume what inside the screen is positive and what outside the screen is negative. All right?
Okay.
So the magnetic field V1 is positive. Is positive. Mu naught I over 4 pi 4 mu naught. Here the angle phi is y over mu naught I pi over 4 pi. The value of R is 2. This is V1.
Okay.
This 3 is the same as V1 but outside.
So it's negative.
Exactly. So this will cancel this. So the remaining is V2. V2 would be mu naught I bar over 4 pi multiplied by 4. Pi will be eliminated with pi. So mu naught I over 16. Mu naught is 4 pi 10 to the power minus 7. The value of pi is 2 ampere. And here I eliminated 6 over 16. So it would be this is this with V2. So I have pi over 2 10 to the power minus 7. Pi over 2 multiplied by 1 expansion 7 negative would be 1.57 10 to the power minus 7 or zero point 0.1. The answer is D.
Oh, okay. So here B1 and B3 cancel, right? So we're only left with B2.
Actually, 1 and 3 cancel each other. So the only one is 3.
Oh, okay. All right. And so, doctor, here you apply the Ampere's law, صح?
What?
In these type of questions, you apply Ampere's law, right?
Yes.
Oh, okay. So like anytime there's like a surface or something, I have to apply the Ampere's law?
Yes. Yes.
Okay. Doctor, what about this question here?
The figure below shows a wire carrying current I in the direction shown. 4 small elements of current are indicated by 4 rectangles. Rank the strength magnitude of the contribution of the magnetic field by the 4 elements of the current. Okay, let us look at element A, B, C, D. Okay, at the beginning, element D is 0.
Yes.
And element B the distance between element B and the observation point is the minimum. Here, we are going to return to Poisson law, where we say that delta B is mu naught I ds cross the unit vector R over R square. So the smallest distance, the greatest magnetic field. On the other hand, the longest wire is a maximum magnetic field. So for the element B and element C, the distance is R or D. The distance here is D. But the section B is twice in length than C. So B is greater than C. And the section A is far away and with an angle. So I am expecting that C is greater than A and A is greater than B. So effectively, D is smaller than A is smaller than C is smaller than D. I think that the correct answer is
See. Okay. And sorry, Doctor, so you said that B, the distance is D or 2D?
I have two parameters. I have what is the length of the current element. So for B, the length is 2D and the spacing is D. So I have the length, the greatest length and the smallest distance. For C, I have smallest distance, but A, I have large distance.
Oh, okay.
Okay.
Yes. One second. What about this question?
We have three conductors. Coaxial cable is constructed as follows. A is the central bar, center infinite wire carrying current 1 ampere outside the page. Actually, you have solved something similar in the review. Here, I have current I, 1 ampere out of the page, infinite conducting cell at a radius 15 centimeter, 0.15 centimeter, carrying 4 ampere, and another one at 0.25 centimeter, 3 ampere. So this is 4, this is 1, and this is 3. And here, 1 ampere out of the page, so this is out, 4 ampere into the page, 3 ampere out of the page, so this is out. What is the direction of the magnetic field in region 2? Region 2 here. So I'm going to say that the integration of B dot ds will be mu naught R enclosed. Actually, it is not interested in the magnitude, but it is only the direction. So I have 1 ampere outside and 4 ampere inside. This means that the magnetic field in this case would be counterclockwise. Clockwise in this direction. Because I have the total enclosed current, it would be 4 inside minus 1. So it will be 3 ampere inside.
Okay, and the current would be in clockwise direction?
Exactly. So the current, the total enclosed current would be inside because it is 4 inside and 1 outside. So 4 inside and 1 outside would be 4 minus 1 would be 3 inside. 3 inside, put your thumb inside the direction of the current, rotate your 4 fingers would be clockwise. So the direction of the current would be clockwise. The direction of the magnetic field would be clockwise.
Oh, okay. All right.
Right?
Mm-hmm. And doctor, I just want to ask this question here. It talks about tension. Would that be included or would it be not excluded?
This is
Tension in
include.
the wire.
This is include because here I'm talking about the magnetic force. The magnetic force it would be uh, vertical support wire. You have a wire of mass 50 gram of length 40 centimeter in suspension horizontally by two vertical wires which conduct current 8 ampere as shown. The magnetic field in the region into the paper. So the magnetic field into the paper. I, I cross B would be the magnetic force. So the magnetic force FB would be downward. The magnetic field in the region into the paper and the magnitude is 60 meters. What is the tension in either wire? So effectively here, I have the weight plus I have the weight plus the magnetic force. So the weight I have 50 10 to the power minus 3 multiplied by 9.8. This would be the gravitational force Fg and Fb would be I L B. I is 8, the length is 0.4, 8, 0.4, magnetic field is 60, 10 to the power minus 3. And effectively, the gravitational force and the magnetic force are downward. The tension in the two wires is the total force over 2. So I'm going to calculate the total force F is FV plus FG, and the tension is the total force over 2. So from here, I'm going to say that 50 expansion 3 negative times 9.8 plus 8 multiplied by 0.4 multiplied by 6 expansion 3 negative. This is the total force divided by 2 would be 0.34. So the answer is B.
And doctor, why did you divide the tension by 2?
Because actually I have two wires. So each wire supply half of the force.
Oh, okay. All right. Doctor, what about this question here? This is the last question.
Three long wires parallel to the x-axis carrying current as shown. If I equal 20 ampere, what is the magnitude of the magnetic field at the origin? So this is quite simple. Actually, I have current. This is the origin, and the distance here is 2. So assume that this is 1, and this is here. So V1 is mu naught, the value of I for I over 2y. The value of R is 2 meters. And this would be inside the screen. V2 would be mu naught. The current is 3I over 2y. The distance is 1 meter, is 1. The direction here is inside the screen for the current in this direction. الثانية احنا الأولانية على فكرة the current in this direction, so the magnetic field is inside the screen. Okay?
Yes.
The third one, D3 is mu naught multiplied by I over 2y. The radius here is 3. And this direction, it will be outside the screen. So the total magnetic field would be V1 plus V2 minus B3.
But doctor, if B3 is outside, shouldn't B1 also be outside?
No. Here it is in negative y. So put your thumb in the direction of the current, rotate your 4 fingers at the region of the origin. You will find that your 4 thumb is outside screen now.
Yes.
So from here, mu naught I over 2y. Here I have 4 over 2 plus 3 over 1 minus 1 over 3. So this is 2 plus 3, 5. 5 minus 3 would be 4 to 3. Okay, we can calculate it. So this is 4 by 10 to the power minus 7. The value of I is 20 over 2y. And here, as I said, we have 5 minus 1/3. So 5 by 3 is 15. So this is 14 over 3. This is 2 bar. I have 2 here. So I have 2 multiplied by 20. 2 multiplied by 20 multiplied by 14 over 3. 10 to the power minus 7. So it would be, the answer is C. It is 18.6 microns. ماشي؟
ماشي. هو دكتور I have a question. هو هنا ال negative signs بتاع ال length, does it matter when we're looking at the direction?
Actually, I'm looking for the distance. I'm looking for the distance from here to here. So the distance from here to here is 3. From here to here is 1. From here to here is 2. I'm saying that if I have a wire and the distance r, so B is mu naught I over 2 by r.
Okay.
So this is the value of r. I'm talking the magnitude of r.
بس like my question is يعني does the
Negative 1 and negative 3 indicating that it is in the opposite direction of the y-axis, or from the x-axis. One is
Okay.
above and one is down.
Alright, بس يعني would it affect the direction?
Affecting the direction I have included by my right hand.
Okay, fine. The negative sign does not change anything, صح? We're only
لا, it will not be added at all.
Oh, okay. But the direction is only determined by the right hand rule. The negative sign is not affected. Okay, all right. This was actually my last question.
All right.
I'll stop sharing. Thank you so much, yeah, Doctor. I really
You
appreciate
are most
your help.
welcome.
Thank
And
you.
I'm going to send you the recording.
Yes, please.
Starting from the recording.
Yes. Thank you so much, Doctor. Have a great
You are
day.
most welcome.
Bye.
Have a nice night and best wishes for you.
Thank you, Doctor.
Thanks.
Bye.
Bye.